Good morning, friends. Welcome to this session. So, in this session, we will study about the experiment number 6, that is design of simple hydraulic systems used in practice using manufacturer's catalog and analysis using software such as Automation Studio. So, instead of Automation Studio, we are using the Festo software here, that is demo version. So, course outcome for this experiment is to describe the design of hydraulic and pneumatic circuit using manufacturer's catalog and simulation using any suitable software. So software, I will be using the Festo software. Then at the end of this experiment, students will be able to draw the circuit diagram of hydraulic system used in practical application. So you can consider any practical application like pressing, bending, drilling, and based on that you can draw the hydraulic circuit diagram. Then student can also design and calculate the discharge and power of the hydraulic system. So how to calculate the discharge and power, that we can easily find out. Then select the components of hydraulic system using manufacturer's catalog. Then finally, analyze the hydraulic system using any software. So whatever the circuit we are studying theoretically, so that we can simulate in the software. So what I am doing for our experiment number 6, I am considering the title, that is design of simple hydraulic system used in practice using manufacturer's catalog and analysis using software. So I am considering here the application, that is hydraulic pressing circuit using double pump. So I will be using here the double pump circuit. So double pump circuit already we have discussed in the unit number 4, that is industrial hydraulic circuit. So working, so what I will do, I will consider the application. So what we will do, let us consider a press cylinder. So here the cylinder I am considering, it is the hydraulic cylinder. It is having a bore diameter of 140 mm. So bore diameter means piston diameter is having 140 mm, and 100 mm diameter of the rod. Rod diameter is 100 mm. And it is having the initial approach of 5 meter per mm and final pressing speed of 0.5 meter per minute. So you can see that when the workpiece it travels very fastly, and uh, it reaches to the component. So that time the speed has to be fast. So that's why the feed rate here is the 5 meter per mm, 5 meter per minute. Then afterwards, when the while doing the pressing, that time I require the higher pressure. So that time the flow rate has to be reduced. So that's why the flow rate is 0.5 meter per minute. Then the system pressure for rapid approach is 40 bar. Okay. Then for the final pressing is 350 bar. So you can see that for 5 meter per minute, 5 meter per minute. Okay. So that is the rapid approach, and the pressure here is 40 bar. Okay. Then for the final pressing, you can see here, that is the speed is 0.5 meter per minute, and the pressure is 350 bar. So from this only we can come to the conclusion that what are the circuit for this application, it will be the double pump circuit. So you can observe here is that 5 meter per minute, it is the high speed. High speed means high flow rate will be there. So high flow rate and low pressure, high flow rate and low pressure. Then 0.5 meter per minute means it will be having the low flow rate, low flow pump with high pressure. So high pressure it is 350 bar. So a two pump, that is high low system, is to be used. Overall efficiency is assumed to be 0.85% for all the pumps. So two pumps I have to use here, that is one is the high flow pump and low flow pump. Okay, so for the efficiency is here 85%. So here what I will do, I am considering one applications. You can see here in the diagram. Okay, so this is hydraulic. I am here using the hydraulic cylinder. You can also use the vertical cylinder, but in this circuit I am using the hydraulic cylinder. So for that application, I am considering is the bending. So for bending the different metals, that is the mainly the thickness of the metal will be high, so that I have to give the shape to that metal. So here the shaping is given in this way. So we can also give the shape of the that is curve in this way also I can give. So mainly this circuit is for the this bending the metal component. Okay, so this is our circuit diagram. So circuit diagram, what I have to do, I have to consider two pumps as from the statement. That is, one is the low flow pump. Okay, low flow pump. Then second one is the high flow pump. Okay, since the low flow pump is there, so for the low flow pump, here we will be having the higher pressure. Okay, HP, higher pressure. So since here high flow pump is there, so here the pressure will be low pressure, that is LP pump. So either you can call it as low flow pump, this one, or you can call it as the high pressure pump. In the same way, that is the second pump, I can call this as the high flow pump or low pressure pump. Okay, so for this we'll be using the filter, then tank, oil will be coming from the tank. Same way, if oil will be coming from the tank, then it will be filtered, then it will be going to the high flow pump. Okay, then one thing you can observe here is that for the high flow pump, what I am using, the connection is such that it is there. I am using the unloading valve. So what is the function of the unloading valve? The function of the unloading valve is that it unloads the oil. That is, it unloads the oil means it dumps the oil to the tank at the lower pressure or the no pressure. So since here the pump is low pressure, so for the low pressure I have to use this unloading valve. Okay, so from the unloading valve, oil will be returned to the tank. Then the high pressure pump is there. For the high pressure pump, I am using this pressure relief valve. So pressure relief valve function, we know whenever there is the excess pressure, so that time what happens, the pressure relief valve will open and that excess pressure oil, it is released to the tank. Okay, in this way the oil will be coming from the high flow pump, then oil will be coming from the high pressure pump and low pressure pump. Then we are using this 4x3 DCV, 4x3 DCV, and it is manually operated DCV controlled by the lever. Then it is the spring return, so manually operated spring return DCV. And center position you can see here is that, so we will be having normally four ports, that is pump port, then T port, then actuator ports, that is A, and actuator port B. So normally four ports are there and the center position is closed one. So first, when I operate to the first position, that time the extension will be done. When I operate the second position, that time the retraction will be done. So the oil will be going to the double acting cylinder. Okay, so initially what is happening? The uh, cylinder will travel. Okay, so it will travel for 5, how much? 5 meter per minute. Okay, 5 meter per minute. Then afterwards the pressing will be done. So for the pressing, the velocity, that is speed, will be 0.5 meter per minute. Okay, so one thing is here is that, one thing we have to observe here is that, so at the first rapid approach, that is for the 5 meter per minute, that time the oil supply will be majorly from this high flow pump. So when the high flow pump, the oil goes, then only I will get this 5 meter per minute. Okay, then finally for the pressing, that time the low flow pump will be operating majorly. Okay, and that time the oil from the high flow pump, it will be going to the unloading tank. Okay, in this way the finally the pressing is done, and while the retraction will be as fast as possible, because the oil supply will be from both low flow pump and high flow pump. Okay, so this much is clear about the working of the double pump circuit. So next step is that we have to design the components. We have to design the circuit. So here what I am doing. So this is this circuit diagram which I have drawn in the Fester software. So in the later video, what I will do, I will explain you about this simulation part, and that we will come to know. Okay, so now we will go for with the design part. So in the design part, we have to see first the design procedure, how to calculate the that is flow rate and the pressure. Okay, so from the given problem, we know that the bore diameter is 140 mm. So I will convert it into SI unit, that is 0.14 meter. Then rod diameter is 100 mm. So it is in SI unit, it will be 0.10 meter. Okay, so calculate the area of piston, then area of rod. Area of piston is equal to pi by 4 dp square. Then area of rod will be equal to pi by 4 dr whole square. So finally, I will get this answer for area of piston, that is 15.39 into 10 raised to minus 3 meter square. And for the rod, I will get 7.854 into 10 raised to minus 3 meter square. So then what we will see for the DC spool position 1. So DC spool position 1 means what? It is the extension stroke, that is nothing but the forward stroke. Okay, forward stroke. So for the forward stroke, first I will find the flow rate, that is discharge. So first what I will do, I will find the flow in the cylinder for the rapid approach, because for the forward stroke, we know that there are two approaches. One is the rapid approach where the velocity is high. Then that whatever the press tool is there, it will come very fast. Then afterwards, the next step is the pressing. Next step is the pressing. So for the rapid approach, the speed is 5 meter per minute. So I will consider it as the V extension, velocity for extension part 1, that is 5 meter per minute. So for the extension, the oil will be going to the piston of the cylinder. Okay, oil is going inside the piston of the cylinder. So I will consider area of piston. So we know that by continued equation, flow rate is equal to area into velocity. So area of piston multiplied by the V extension 1. So I will get 0.0769697 meter cube per minute. So it is in meter cube per minute. I will convert it in terms of liter per minute. Liter per minute. So liter per minute is what? Just multiply here with the 1000. Okay. If you multiply by 1000, then I will get 76.97 liter per minute. So this is the flow rate for the rapid approach. Then next I have to find the flow for the pressing. So for the pressing, the speed is 0.5 meter per minute. 0.5 meter per minute. So that I will call it as the V extension 2. V extensions 2. So Q extension 2, that is will be the flow rate for the pressing. So again multiply with area of piston. Because the oil is flowing to the area of piston only. Okay, so finally what I will get? I will get 7.693 into 10 raised to minus 3 meter cube per minute. Okay, so then multiply with the here with the 1000. So then I will get in terms of liter per minute. So 10 raised to minus 3 into 1000. So they will get cancelled. I will get 7.69 liter per minute. So what we can observe here is that the flow rate is maximum in this first stroke, that is the rapid approach. Flow rate is maximum in this first, that is rapid approach. Okay, so now we can say that the discharge of the high pressure. Okay, discharge of the high pressure. Discharge of the high pressure, that is low flow pump. High pressure means, already I have said, high pressure means it is low flow pump. So for the low flow pump, it is 7.69 liter per minute. And discharge for low pressure, that is low pressure, that is nothing but the high flow pump. High flow pump. So what I am doing, 76.97 minus 7.69. So this will be the discharge for the low pressure pump, 69.2. That is the high flow. why I'm making the difference of 7.69, because at the time of rapid approach, the oil will be coming from both the low flow pump and high flow pump. Okay, but while pressing, what is happening? While pressing, that time the oil will be coming from the low flow pump. Okay, so that's why I'm making the difference of this 7.69. So 7.69 is for the low flow pump. 7.69 is for the low flow pump. Then this 69.28, it is for the high flow pump. It is for the high flow pump. And this total discharge will be around 76.97. So which will be the addition of the low flow pump and high flow pump. Okay, so therefore what we can see that the maximum discharge in the system, considering the low flow pump and high flow pump, it will be the high flow pump, that is 69.28. It is the maximum discharge in the system. We are not talking here about the total discharge. Here we are talking about the maximum discharge of the pump. So maximum discharge of the pump is the high flow pump, that is 69.28 liter per minute. Okay, then we will calculate the power. For the high flow pump. Okay, for the high flow pump, the power will be equal to pressure multiplied by discharge. Okay, so pressure for the high flow pump is 40 bar. It is given in the statement, 40 bar. Okay, so what I will do, 40 bar, I will convert it in terms of Newton per meter square, 40 into 10 raised to 5. Then the flow rate for the high flow. See, I am talking here about the high flow. So student may get confused there. So you have to carefully do this problem, this design procedure. Okay, so high flow pump. So here only you have seen high flow pump. It is 69.28 liter per minute. So multiply 69.28 into 10 raised to minus 3. I am again converting it into meter cube per second. That's why I'm multiplying 10 raised to minus 3 and divide by 60. So the high flow pump power will be 4.62 kilowatt. So you should come to know high flow means what? It is low pressure. So low pressure और high flow दोनों सेम ही है, ठीक है. Low pressure pump power is equal to 4.62 kilowatt. So since the motor power efficiency was given, it is around 85% overall efficiency. So what I will do, I will divide it by overall efficiency. Okay, so then finally I will get the motor power 4. That is 5.43 kilowatt. That means I am getting the power from the motor, that is 5.43 kilowatt, but the pump will be giving 4.62 kilowatt. Why? Because of the efficiency losses, that is 85%. Okay, then we have to calculate the power for the low flow, that is high pressure pump. Okay, for the HP, high pressure pump power is equal to what? Same, that is pressure multiplied by discharge. So pressure for the high pressure pump is 350 bar and the discharge is 7.69 liter per minute. So multiply that one, that is 350 into 10 raised to 5, then 7.69 into 10 raised to minus 3 divided by 60. So this I am converting into liter per minute into meter cube per second. So then I will get high pressure pump power is 4.49 kilowatt. 4.49 kilowatt. Since we know that the motor efficiency is 0.85%, that is overall efficiency is 0.85%. So what we have to do, we have to divide it by overall efficiency, that is 0.85. Then I will get 5.28 kilowatt. That means for the high pressure pump, it is the motor power is 5.28 kilowatt, but the pump power output, it will be 4.49 kilowatt. Okay, then we have to calculate the motor power required for the single pump of 350 bar pressure. Okay, if I am using this single motor, okay, that is for the single pump. If you are using the only single pump that is of 350 bar, then the motor power is equal to what? Pressure multiplied by Q. Okay, so that the pressure here is 350 bar, and I will take the maximum discharge, that is total discharge. If I want to use the only single pump, I am here we have to consider for only single pump. So it will be 76.97, that is total discharge. So calculate 350 by 10 raised to 5 into 76.97 into 10 raised to minus 3 by 60. And again, we have to multiply this 0.85. So then motor power will be 52.82 kilowatt. So one thing you can observe here is that if I am using only single pump and I am considering this one, maximum pressure and this total discharge according to the system requirements, so then the motor power required will be 52.82 kilowatt, which is very much high. So that's why what we are doing, we have to use the two pumps. One is the low pump and high pump, that is low flow pump and high flow pump. So the savings in the power we will see. If we use two pumps in the system, then the savings in the power will be, so what is this for single pump, the power is 52.82 kilowatt, 52.82 kilowatt. Then add the single that is the two pumps, low flow and high flow, it is 5.28 and 5.43. Okay, so then what I will get, 42.11 kilowatt, this much power I am saving when I am using the two pumps. So this thing, in this way we have to design, that is we have to see the requirements, and unnecessary we should not waste the power. So if I can also use this single pump instead of two pumps, but the unnecessary there will be the wastage of the power, and that's why to avoid that thing, what we are doing, we are using the we are using two pumps, that is one is the low flow pump, okay, and one is the high flow pump. Okay, in this way we have to consider for the system design. So 42.11 kilowatt savings we are doing by using the two pumps. Then next thing is about the selection of the components, different components. You're seeing that tank is there, filter is there, then DC, the unloading wall is there, and pressure relief wall. So how we will do their selection? So for their selection, we have to consider this manufacturer's catalog. Okay, using this manufacturer's catalog, we are doing the selection. So first selection I will do for the reservoir. Okay, oil reservoir. So for first one is the low flow pump. So low flow pump, it is 7.69. Normally the capacity of the reservoir, it is the 3 times the flow rate. 3 multiplied by the flow rate. So 3 multiplied by 7.69, it is 23.07 liters. So I will go to the catalog. I will see where 23.07 will come. So it will be 23.07. It is below this 40 liters. Okay, it is below the 40 liters. So what I can say, I will select this 40. So T1 is 40 liters. So this is the maximum flow capacity, and I will get this size. The component name will be T1. Then for the high flow pump, the flow rate is 69.28. What I have to do? Multiplied by 3. If I multiplied by 3, then I will get 207.84. So come here to the catalog, see where the 207.84 is come. So it will not come under 100. Okay, but it can come under 250 because 2075 is less than 250. So, and it is greater than 100. So it will definitely come in this way. So the size of the tank will be, that is model will be T3. So I will be selecting T3 model. So T3 model, the maximum flow capacity is 250 liters. Then next come for the strainer. Okay, strainer for the low flow. So strainer, if you see model and flow capacity is there. So flow capacity, it is a liter per minute. So come here. So flow rate is how much? 7.69 liter per minute. So see here where the 7.69 will come. So 7.69 will come under this 38. Okay. So directly I will select S1. So here S1 is there and its maximum flow capacity is 38 liter per minute. So whatever this size I am selecting, whatever the model I am selecting, that's a value only I have to consider here for the maximum capacity. So maximum flow capacity is 38 liter per minute for low flow pump. Then coming to the high flow pump, the flow rate is 69.28. So let's see where it comes. So 69.2, it is greater than 38 and less than 76. So 69.28, it will be easily occupied in this S2 model. Okay, it will be easily occupied in the S2 model. So consider this value. So S2 is 76 liter per minute. So its maximum flow capacity is 76 liter per minute. Then coming to the next component, it is the pump, vane pump. So first I will consider for the low flow. So for the low flow means what? See, that's why I'm writing here. Low flow means what? In the bracket, I'm writing it as the high pressure pump and its maximum pressure is 350 bar and the flow rate is 7.69 liter per minute. So come here, you can see that the pressure ends here only 35 bar, 70 bar. That is the maximum one. So we don't have here 350 bar. So that's why what I am doing here. So I am not a model. I can't select from the catalog. So that's why I am writing itself here that low flow and high pressure pump, the maximum pressure 350 and flow rate 7.69 liter per minute. So in this way, you have to write. Then coming to the high flow pump. So again, if we come to the high flow pump, the pressure is there 40 bar. So 40 bar will occupy here, but the flow rate is 69.28. So 69.2 value is nowhere here. It is more than 37.5. So almost double the value of 35. So that's why again I can't select the model here. So what we have to do, I am writing here high flow, then low pressure pump. The model itself is high flow, low pressure pump, and the maximum pressure is here 40 bar and flow rate will be 69.28 liter per minute. Then coming to the check wall. So check wall, if you see the check wall model, okay. So check wall, the working pressure is 210 and flow capacity is 7.6 liter per minute. Okay, that is 76 liter per minute. So one thing you can see, the flow check wall, where we are getting the check wall. So check wall is coming in this line. Which line? High flow pump line. So check wall is coming in the high flow pump line, and high flow pump, the discharge is how much? The discharge is 69.28. Okay, so 69.28 will be easily occupied here in the 76 liter per range. So that's why I will select C3. So you are going to select C3. You should select C3, and its working pressure is 210 bar. 210 bar and flow capacity, that is 76 liter per minute. Then when we come to the pressure relief valve, so if I see the catalog, so the pressure ends here only 210 bar. And where we are using the pressure relief valve? Pressure relief valve we are using for the high pressure pump, and high pressure, the pressure is 350 bar. Okay, so that's why just write down the same model will be there. That is low flow high pressure pump. So same model we have to consider, and I am writing here that the pressure is more than 350 bar and the flow rate is 7.69 liter per minute. In same way, unloading wall, in the catalog we don't have the option. So unloading wall is connected to the high flow pump. Unloading wall is connected to the high flow pump. So that's, I will be writing high flow, low pressure pump. Pressure is 40 bar and flow capacity is 69.28 liter per minute. So again, next is the direction control wall. We are using 4x3 direction control wall. If you see the value here, so the direct maximum pressure, we are getting 350 bar, but the flow rate for the 350 bar is 19. Suppose if 76 was here, so then we would have considered D1. So we can't consider this one. So that's why I'm writing here is that pressure is more than 350 bar and flow capacity is 76.97 liter per minute. Why 76.97 I am considering for the direction control wall? Because in the direction control wall, the oil will be coming from the both low flow pump and high flow pump. So that's why I'm considering here is the 76.97 liter per minute. Then cylinder, selection of the cylinder. So that's why I'm writing here as the dash nil. Then that is same will be there. For the cylinder, if you see, the maximum working pressure is 210 bar, but our system pressure is how much? 350 bar. So that's why we have to select beyond this catalog. So that's why I am writing it as the pressure more than 350 bar. So which are the component size which is not available in the catalog? So write down the component, okay, like I have written here, direction control, and just explain their values here. Explain the values here. Like 350 bar will be for this DCV, okay. Then control wall, that is flow capacity, will be 76.97 liter per minute. So in this way we have to do the calculations for the design of hydraulic system. So in this video we have come to know the that is application of hydraulic pressing circuit using double pump circuit. Then the diagram of circuit diagram of double pump circuit for pressing. Then the design procedure to calculate the flow rate for rapid approach, then press approach, then to calculate the maximum discharge, then the low pressure pump power to calculate the high pressure pump power. Then we are also calculating, we are comparing, that is when we use the single pump instead of two pump. So that time the motor power is 52.82 kilowatt. But when we use two pump, so we are making a saving of around 42.11 kilowatt. Then afterwards, using the manufacturer's catalog, we are going to select the different models which we are going to use in the circuit. Then if the model is not available from the manufacturer's catalog, so then we have to write our requirements, what are the values we have calculated, that we are writing. So in this way we have to do the design of hydraulic system. So similarly you can perform the design of various circuits like drilling and all. So thank you very much for your listening.